Visit Chandra's beautiful universe. RCW 36. Astronomers have found that groups of stars or clusters in certain environments can regulate themselves. The stars in the cluster known as RCW 36 have self-control by limiting the number of stars to grow. They do this when the biggest and brightest stars expel most of the gas from the system, which depletes the cluster of the material new stars need to grow. This process could drastically slow down the birth of new stars and give better agreement with predictions for how quickly stars should be forming in clusters. This study combines data from several telescopes, including NASA's Chandra X-ray Observatory, NASA's airborne SOFIA Observatory, the Apex Radio Telescope in Chile, and the European Space Agency's Herschel telescope in space. The target of the observations was RCW 36, a large cloud of gas called an H2 region, mainly composed of hydrogen atoms that have been ionized, which means the atoms have been stripped of their electrons. This star-forming complex is located in the Milky Way, about 2,900 light-years from Earth. RCW 36 contains a cluster of young stars and two cavities, or voids, carved out of the ionized hydrogen gas, extending in opposite directions. There is also a ring of gas that wraps around the cluster in between the cavities, forming a waist around the hourglass-shaped cavities. Astronomers see hot gas with a temperature of about 2 million Kelvin, or about 3.6 million degrees Fahrenheit, radiating in X-rays with Chandra. Most of the hot gas is concentrated near the center of RCW 36, close to the two hottest and most massive stars in the cluster. Much of the rest of the hot gas is outside the cavities, after having leaked through the borders of the cavities. The SOFIA and Apex data show that the ring contains cool, dense gas and is expanding at 2,000 to 4,000 miles per hour. The SOFIA data also reveals that shells of cool gas on the perimeter of both cavities are expanding at about 10,000 miles per hour, likely being driven outward by pressure from the hot gas observed with Chandra. The hot gas, plus radiation from stars in the cluster, has also cleared even larger cavities around RCW 36, forming a structure like a nested Russian doll. Researchers also see evidence from the SOFIA data for some cool gas around the ring being ejected from RCW 36 at even higher speeds of about 30,000 miles per hour. They estimate mass equivalent to about 170 Earths are being pushed out per year. The expansion speeds of the different structures, plus the mass ejection rate, show that most of the cool gas within about 3 light-years of the center of the H2 region will be ejected from RCW 36 in 1 to 2 million years. This will clear out the raw material that stars need to form, suppressing their continued birth in the region. Astronomers call this process where stars can regulate themselves stellar feedback. Results such as this help us understand the role stellar feedback plays in the star formation process.